Today we're going to look at function rules and how to represent them. We'll sometimes represent things with pictures, with graphs, with tables, and with equations. So we're going to look at all these different types of representations. In this example that we're doing together, it says in the diagram below, what is the relationship between the number of rectangles and the perimeter of the figure that they form? So we're looking for the relationship between the number of rectangles and the perimeter of the figure. So when we look at that, the number of rectangles is the thing that's being controlled. First there's one rectangle, then two, then three, etc., etc. And the result of changing the number of rectangles changes the perimeter of the figure. That's why the number of rectangles is the cause and the perimeter is the effect. So the cause is always our independent variable, or our x, and the effect is our dependent variable, or our y. So we're going to be looking to form a relationship to be able to describe what's going on. So first it says represent this relationship using a table, words, an equation, and a graph. So let's start by just kind of looking at what's going on. As we start to make the table, we can see when we have one rectangle, the perimeter should be 1 plus 6 plus 1 plus 6, or 14. When we have two rectangles, we have a 6 on either side, 2 1s across the top, which also means 2 1s across the bottom. So 4 plus 6 is 10, plus another 6 is 16 for the perimeter. For the next one, we have 6s on either side when we have 3 rectangles. We have 3 1s across the top and 3 1s across the bottom. So that's really 6 times 3, or 18. You might notice that a pattern is starting to develop. If you look here, the perimeter is 14, then 16, then 18. If you had to guess, I bet you'd say that the perimeter is probably 20. And notice you'd be right. We have 6 and 6, which is 12, 4 across the top, which is 16, and another 4 across the bottom, which brings us to 20. All right, taking a look at some of the questions as they're laid out here, you'll see that we actually already addressed this first one. The independent variable here is the number of rectangles, and the dependent variable is the perimeter of the figure. As we examined the pattern, we actually got all the information we needed to make the table. When we have one rectangle, we have a perimeter of 14. When we have two rectangles, we have a perimeter of 16. When we have 3 rectangles, we have a perimeter of 18. And 4 rectangles gives us a perimeter of 20. And we're asked, do you see a pattern in the table? What do you do to the number of rectangles to find the perimeter of the entire figure? Well, we've already kind of talked about the basic pattern. The basic pattern is that the perimeter goes up by 2 each time, while the number of rectangles is going up by 1 each time. So that's a pattern within the independent variables or within the dependent variables. But we need a little bit of a different thing if we're looking at how can we take x and turn it into y. So let's go back to the original figure and think about what stays the same and what changes every time. Notice we always have those tall sides of 6 on either side. So we're always kind of starting with a base value of 12. So if I think of having a base value of 12 with just one rectangle, notice 12 plus 2 gives me 14. And that 2 is coming from this one rectangle. Notice if I started with a base value of 12 here, I need 4 more to get to 16. And notice the 2 rectangles, I've got 2 from the top and bottom and then 2 from the top and bottom, so that's adding 4. For this next one, I would have that 12 as a base value. Notice if you go back to the figures, there's 3 on top and 3 on the bottom. Notice that's 3 times 2 that we're adding, or 6. So it looks like we're taking 2 times the number of rectangles, adding that to the base value of 12, and getting the perimeter. Notice if we test that on this last example, we would say that the perimeter should be 2 times 4, the number of rectangles, plus 12. Well, 2 times 4 is 8, plus 12 is 20, so our pattern works out. That gives us an equation that can describe what's going on in the table. Y equals 2x plus 12. If I back up for a minute and I try to put that into words, we're saying 2 times the number of rectangles is added to 12. That's how we get the perimeter each time. That's a verbal description of what's going on in this pattern. Having trouble scrolling. Finally, we're asked to represent the same relationship with a graph. And that really just means take the points you found in the table and make a graph. Now, this grid happens to be pretty small, so we're going to have to be a little flexible with our scale. If my x value is the number of rectangles, we can see that's going up by ones. So I can use a 1-to-1 scale along the x-axis. But my y-axis comes from the perimeter. And that's going to be too big to be able to go by ones and actually have it fit on the graph. I could try to go by twos if I do 2, 4, 6, 8, 10, 12, 14, 16, 18. But I can see that I'm not actually going to fit on there, so that's going to be a little tricky. I am going to recommend we go by twos just because it's going to get really tricky to graph if we try to go by fours, and maybe next year we'll put a bigger grid. So my first one is going to be at 1 and 14, so 2, 4, 6, 8, 10, 12, 14. My next one's going to be at 2 and 16, then 3 and 18, 4 would be at 20, so we can see that the pattern would be going up off the graph.